Well, I think I got a problem. eBay set me up with 10 of these. It looks like I am going to build a clock. Another one. Like I need another clock. I think I'm going to put 8 of these. This one's a decade counter. Couple mods and I can get this to count as a divide by 6, and then plug them into some edge connectors and a chassis, and we'll have a clock. So with a little help from Heathkit and a little HV supply, and it's counting. Okay, just a quick run through the board. Alright, the only thing that we really need to use on these boards here, 7490, okay, which has DCBA outputs. There's a 7441 here and a 7441 over here. This is the one that's connected to the Nixie, okay? That's the one that's going to create the display. This one over here, alright, this is not used, and all these transistors in this resistor are not used. That, I don't know what these boards are out of. These transistors and this basically is functioning as a 1 out of 10 driver connected with these transistors. There's some external circuitry that was all for. So in the case of this clock, they're just there. I'm going to leave them. No sense yanking all that out. I may just cut the ground to this one so it's not sucking power. So that package is just there doing nothing. But other than that, all you really need, like I said, the 7490 to do the counting, and your 7441, which is early Nixie driver, to do the driving of the display tube. That is it. Got a little test jig set up, and the Heathkit that I referenced. This is the model ET3200. This has actually been kind of handy for this project and a few others. All I'm using on it is the clock signal and 5-volt supply. You can see the logic indicator, the one LED blinking, that's the 1 hertz clock rate. We have a couple different you can select from, 1000 and 100 kilohertz. Some debounce switches if you're messing around. A few other things that are kind of handy, so maybe you want to pick one of these up. It'd be handy to have. This other wiring and IC I have on the side here, I'm not actually using that currently. It's a 7490 on it. That's actually what I was just doing some prototyping with it, just to make sure I knew how to make it count to 6. So that's just, I left that there off to the side. This decade counter is now a 0 through 5 counter. Just by moving a few things around. 7490 here. A Q4 and Q2 outputs independently get jumped to the 0 set inputs. One jumper I ended up putting underneath on the other side of the board. On the top side of the board here, unfortunately, the way the traces were laid out, I had to cut a pin right at the top of the board on the IC. So I bent the pin up after I cut it, and I put one jumper across the top. It was the easiest way to do it. And we have a few more to do, and that'll be it for the 0 to 5 counters. The next hurdle will be figuring out how the 12 counter is going to work on 2 boards. I'm going to have to add a package with some gating, somehow figure that out. That'll be next. Okay, so 0 through 5 counters counting. I have the analog voltmeter hooked up to the Q4 output. Okay, so if you watch the count, 2, 3, 4, Q4 goes high, then goes low. So when it goes low, this is going to advance to the next stage. So that Q4 output from the 0 to 5 counter will feed the next stage. Every time it goes low, the next stage advances a count. So the next stage is going to be a 10 counter, 0 through 9. That output is a QA output that you use to trigger the following 0 through 5 counter. So it's the same thing. 7490 advances a count on a negative going pulse, the trailing edge. So that's basically how that works, and they link together. I don't have an entire enclosure design in my head yet, but I did make this up to get me started on prototyping. I needed something to plug the boards into, so came up with this with just some scrap acrylic laying around. I had the solvent, melted it together, and hopefully I can use this in the finished design. Well, 2 of these are reconfigured. They're counting 12 properly and resetting. 12, skipping a 0, starting at 1. It was a little bit of a challenge. We got it though. Just added a 7400 quad NAND gate. And didn't hack up the boards too much, so I think it was a success mission. Okay, 12-hour counter. Hours position, tens of hours position. 7490s in both places. Alright, this one's going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then back to 0. Alright, at the same time that goes back to 0, this D line drops low, clocks the next stage to a 1. Equivalent display will be a 10. Alright, and then this one continues 1, 2. The instant this hits 3, alright, you got 2 lines high, your A and a B. That's the only time all the NAND gates, the condition will be satisfied for a reset. Alright, this one high and then this one going to a 3. Okay, a little on the 7400 NAND gate. You can look it up online, see the data sheet, get the truth table, but real quick here, the only time you get a low output on it is when both inputs are high. Any other condition on the inputs, the gate output stays at high. Okay, so both inputs high, you get a low. Now the 7490 0 reset, when both pins are high, alright, it's going to reset to 0. Either pin low, it counts normally. Okay, so on the ones of hours counter, you see the 2 NAND gates here on the right. We got our B output and our A output connected to the first NAND gate. Alright, that's when both of those go high, which is a count of 3. That's gonna set this NAND gate, alright, to a low, and then this one inverts. Alright, because both those inputs are tied together and it's going to invert. Comes over here, and this one does nothing until this A output goes high. And when these two here are high, alright, then this is going to go to low, and then this one inverts, making this high. Alright, and then remember we talked about our zero reset, both pins high, resets to 0. So that's how that's going to work. So at a count of 13, alright, we have a count of 1 here, and just after the count of 2, going to 3 here, that's when all the conditions are met and you get a reset. Okay, so anyone that's played with the 7490 and trying to make a 12-hour counter for a clock, the trick's been getting rid of the unwanted 0 after a reset. The 7490 resets to 0. One place in a count that you don't want that 0 is after the 12, and you want to roll over to 1 o'clock. Alright, so that 0 is going to go away. So in this count, alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. This goes to 1. Alright, 11, 12, and then in an instant this goes 13. A reset to 0 happens. But you don't want that 0 because you want it to go to 1 o'clock. Alright, this is bounced out. And what actually does that is this simple little capacitor over here. So just for a moment, take this out. That's for time setting. And this interstage connection here actually works with the time setting, so we're going to take that out for a moment just for argument's sake. This little capacitor here, something to do with after these get hit with a reset, there must be just a slight bit of delay here, which provides an extra clock needed to bounce that 0 right out. It works well. Okay, so our connections between stages. The board's plugged in these edge connectors. Whether it's the Q4 or the Q8 output, which is basically just used as a clock signal to the next stage. One is going to be a 10 counter, the other is going to be a 6 counter. The connections between the stages are going to be direct. Alright, so from, like, say, the Q4 or the Q8 output to the next stage is going to be to the clock in of the next stage. So it's going to be directly wired in. Alright, and until you get to a place where you want to be able to set it with a button or a switch, you've got to be able to set the time to your desired time. That's the only time we're not going to use a direct connection, because you're going to have to be able to blend in a setting signal of some sort. Okay? Right? So, when we're going to use this setup here, clock from the previous stage. Okay? In through this diode, a pull-up resistor. We're going to capacitively couple, and what we're going to do with this clock is a 1 Hz signal. We're going to steal that, tap off of that, and blend that in through a button, again through another capacitor. Just take some bounces of the switch contacts out and make a nice clean setting signal to the clock in of the 7490. Okay, so this will allow you to be able to send in your 1 Hz signal just by holding the button in, and it'll advance the count every time, every second, right? Okay, connections are made. Power, ground, high voltage, strung straight across. Interstage connections, some direct, some with the time set feature. Resistor, diode, capacitor, all ready to go. Just have to finish the enclosure. Okay, we have 6 digits, but you're wondering what the heck is going on over here. That's madly counting away. Well, the hours section is not plugged in. Minutes, seconds, and what we have here, that's the 60 Hertz divider. Okay, so 60 Hertz comes into the first one that's really madly counting. That's a 10 counter, gets divided down. Alright, now we have 6 Hertz. Alright, into the 6 counter, that gets divided down. And then we have our seconds, 1 Hertz. Alright, so not too many Nixie clocks out there with that little animation going on. Okay, let's connect the VOM to the divider output. Every time that drops, you see the seconds count. This connected to the interstage connection. The first fire up. Looks like things are working. I just wanted to limit the high voltage supply, so I got it through a resistance substitution box, just so I can dial in the current. I might do a final resistor in series with the high voltage supply to the tubes, and the high voltage is right bang on 170. Happy so far. Well, it seems to be behaving pretty well. We'll talk about the power supply. Well, I tried to use vintage or vintage style components to give it that warm feeling, if you will. So 5 volt regulated supply using a pass transistor. That's fed by the 6.3 winding, 6.3 volt winding on the big transformer here. The big transformer also has a 250 volt AC center tapped windings, and that's providing the high voltage. Center tap goes ground through 2 diodes, and we have a 170 volt output to drive the tubes. The 60 Hertz reference comes out of this board too. It's a diode above ground, and there's an RC network to smoothen out or remove any unwanted spikes which would make the clock count fast. So that output, once conditioned, is fed out to the first 7490 toward the frequency divider that we talked about. That's about all there is to talk about there. Some switches on the back. Alright, we have a hold switch, minutes, tens of minutes, and hours set buttons. And I also incorporated a high voltage disconnect to shut the tubes off when you want it to go dark, if you will, but it'll still keep time, so it'll save tube life. Nothing fancy on the line cord. Back then everyone knotted them in there. I put a little hot glue just to keep it from sliding around, rotating. Other than that, I did not want to put a strain relief and fight that into this plexiglass and risk busting up, cracking the plexiglass. It was nerve-wracking enough building this enclosure. I did not want to finish it off with breaking it doing the power cord. Other than that, that's all she wrote. I'll slip in a scope shot of that 60 Hertz reference, the conditioned 60 Hertz reference, right here. I do hope you enjoyed this build, and thank you for watching.